Hi there, today we'll be doing palindrome linked list. So here we have, let's do understanding first. To understand this problem, we have to look at a couple examples. So what we're trying to do is return an output of Boolean, true or false, and as long as we can read the front to the back and back to the front equally, then they are palindrome. Okay, so what we have here, so what can the items of the palindrome be? Well, the items can be of value 0 through 9, and the total number of items is about 100,000. 10 to the 5th power, yes, 100,000. So this is one case, and the other case is non-palindromic. So we have 1, 2, as you can see. That would be returned false. So what would be a edge case? An edge case would be like completely empty. With a completely empty, I am assuming like, oh, it starts with 1. There's always one item. So that's going to be our edge case. It's one item will always be true. Okay, and this is going to be false. Okay, so our time complexity will definitely be O of n, because we do have to process the entire linked list to know for sure whether or not it is a palindrome or not. And a space is going to be O of 1 because we don't need any new space, we just need some pointers. So what's the match? What we're going to match is we're going to have 2 pointers. First, the reason why we need 2 pointers is because we do need a slow and a fast to split the 2 lists in half, so that we can reverse 1/2 of the list and check if the 2 lists are equal. If the 2 lists are equal, then we can like say they're palindromic. Okay? Because currently, if we had a doubly linked list, we could just move from both ends of the linked list towards each other, but we don't. We have a singly linked list, and that means we have to reverse the linked list for us to be able to get the same sort of result. Okay, so reverse linked list. All right, let's do the plan. The plan is first find halfway point in linked list. 2, reverse second linked list. And 3, check if both linked list is equal. If not equal, return false, while L1 pointer and L2 pointer, like when while loop ends, return true. Okay, so that's what we need to do, and let's implement it. So to find halfway, we need a slow and fast pointer. So let's put this in to the top. And to get halfway, we just need to move these items forward. And so what would be the problem here? A problem would be if head.next equals none, return head. I mean true. Okay, so what happens here is that if while fast.next, is that possible? That is possible. Otherwise, we would have this particular result here, fast and fast.next and fast.next.next. That looks kind of funky, but it also works. Okay, so let's check it out. Let's see what happens with one item. Okay, slow and fast remains at the same place. So one item. Well, that doesn't occur. Two items. So slow is here and fast is here. Fast ends. So what we're gonna split in half is that we're gonna take the slow.next. So what we're gonna do is slow temp list2 is equal to slow.next, and list slow.next is equal to none, because we don't want this pointer to exist anymore. We want to cancel. We want to split the list in half. Okay? So list1 is equal to head. All right? So let's check 3 items to make sure that that works for us. So fast moves into this location, and slow moves over here. Okay? And so we're going to check the 3, or that's going to be our slow. And slow.next will be empty, so there's no pointer here anymore. And now we're going to have to reverse it, so it'll point back to 2 later. But we don't have that right now. Okay? So everything's looking good for 3 items. Let's see what happens for 4 items. So 1, 2, 2, 4, 1. So slow and fast. So fast moves over here. Slow moves over here. And so this means that this is going to be our slow.next right here. And there's not going to be a pointer here anymore. So that's perfect. So list1 is here. And list2 is going to be right here. So what we need to do is reverse the second list right now. So everything's looking good for us. So how do we reverse a linked list? So L2 So first we need a dummy node. Or a none. Well, prev is equal to none. Let's set that as prev. And well, not there. Prev is here, none. We'll set that to prev. And we'll set this to current. Current is equal to L2, or list2. And list2 dot next is equal to prev, and prev is equal to list2, and we do need a temp. So temp is equal to list2 dot next. So this is going to be our temp. We're going to move the pointer this way, point to none, right? And oh, one more thing. So yeah, we pointed that to none. Perfect. So that points to none. Great. And now we need to point this item. 1 now points to 2, which is previous is equal to list2. So previous is now equal to list2. And current this is current.next. So current is equal to temp. And then while current, of course. So while current still is running, temp is equal to current.next. This was pointing to none. And list2.next, oh, that's not right, it's current.next. So current.next is going to point to prev. So there we go. And now prev is equal to current. So, all right. And not list 2 is list 2 is remaining here. We're not changing list 2. Previous is equal to current, and current is equal to temp. Perfect. So previous is going to be the beginning of the start of list 2. So list 2 equals previous. So with that, we are done with reversing the string. I mean the linked list. So reverse and split in half. And with that, we have list 1 and list 2. Check while list 1 and list 2. So while list 1 and list 2, if list 1 equals list 2, that means we can return true. That means they're the same item. Yeah. So if elif list1.val does not equal list2.val, we can return false. Actually, I don't think we need this line, because even if it's even or odd, like 1, 2, 1, this points to 2, right? And this one points to none. This one also points to, wait, actually that's not true. It also points to 2, doesn't it? So they all both point to 2. Is that right? I'm not sure about that. Because, okay, let's run through this code, because I'm not sure what this 1, 2, 1 does at this point. But let's check it out to make sure that we are doing exactly what we're planning to do. So we have 1, 2, 1. Making sure we split in half. We have slow and fast pointer. So fast is going to go to the end, and slow is going to be at 2. So that means slow.next is going to be none. And slow is going to be, or this is going to be list 2. List 2 is going to be right here. List 1 is going to be right here. Okay. I don't think that is what we want to do. Because what happens here when we set list 2, slow.next to be none, is that it is impossible for us to set it, so previous to, I mean, we're going to set it to none, right? Previous is going to be none. But this is a different none, right? And if we set this to be previous, then, and current to be list 2, and while current, we'll set the current to be, you know, to point to the previous. The problem here is 1, and these are this is a palindrome, but unfortunately these are not equal, as you can see. So this cannot be none. Okay, so suppose it's not none. Okay, so now what? It's still pointing to 1 right now, right? So let's set the previous to slow. Okay. So previous is now equal to slow. Current is equal to slow.next because of list 2. Okay. And what we're gonna do is while current, so current exists, we're gonna flip the sign and point it back to 2. And perfect. We've done it. And we can move these forward and that we're pointing to the same thing. So what happens is that if they're equal list item, then we should return true. Okay. However, in an even case, so in an even case, let's create the slow and fast pointers again. Slow, fast. So slow, fast moves here, slow moves here, and now that means this is going to be list 2. This is going to be list 1. Okay. And what we're going to do is this is going to be previous, and that is going to be current, right? And so basically what happens when we have this is that we're flipping all the signs. So what happens here is that this now points to 2, right? And this previous moves forward, this current moves forward, and that points to 2. So as you can see here, this is what the linked list will look like. And with that, and we look at list 1 and list 2. This is where it begins. And so list 1 and list 2 is the same, but as you can see here, list 1 and list 2 is the same. However, list 2 is not pointing to anything whatsoever right now, okay? List 2, well, actually, it's pointing that way into the 2. And list 2 is pointing that way into the 2. So this will go over here, and this will move over there, okay? And now you have an infinite loop because these just keep swapping between each other, as you can see. So 2 will point back at 2, and this will be infinite loop. And right, so how do we resolve this? Well, I'm not sure. Do we have to have a count maybe, or something? Does it have to be even or odd? What can we do? 1, 2, and then points to nothing. 1, 2 points to, well, each other. So this is what it actually looks like. We could have a hash to say we've seen it before, but that's not the best solution. All right, so I did some introspection, and what we should do instead of the earlier example, so we don't end up in an infinite loop here, is set slow.next to equal to none. What I saw earlier, because this way, this points to none, and the previous is actually equal to slow. So this way, we could also do 1, 2, 1 properly. We did that improperly earlier, so we have a slow and fast. And so now we move the slow and fast pointer. So slow is here. So now we have a list 1 starting here, and we have a list 2 here, because this is slow.next, right? And what happens is that the previous is at slow, so this is the previous, and this is the current item. So slow.next is equal to none. So this now points to none. this is actually slow.next. This is current. All right, slow and fast, yeah, we don't care about those anymore. So with that, we can point 1 to previous, which is 2. So this points straight to 2, and that way we have 1 points to 2 and then points to none. So 1, so 1 points to 2, points to none. 1 points to 2, points to none. So they're equal now. Okay. So for the even side, what happens is when we set it to none is we're gonna have to reset this. Is that we have a slow and fast pointer once again, and then we move to fast and we move to slow, and so slow is going to previous, and fast is going to be well, I mean slow.next is equal to, I mean list 2 is equal to current, which is slow.next. So this is going to be current. Okay, I think this makes a little bit more sense. Like if we just did this instead, this doesn't make much sense. Okay, and this 1 equals head. Let's move that code down here. Okay, so we set slow.next is equal to none. So that's none now. And current is going to point back at 2. So this is going to point back at 2. And now we're going to move the previous and the current pointer to here, and we will reverse those as well. So 1, 2, 1, 2, and then 2 points 2. Well, at this point, but what it's pointing to is well, 2, the slow right here, the previous. So it's going to break the loop and return true. Let's run the code. All right, let's submit, and then we'll do some review afterwards. Okay, let's say it worked, and the review is, I think we've done a lot of review actually, and because 1 points to 2, points to none, and 2, and that's 1 points to that, and that points to none. Eventually, one item gets to none, and then they basically you return true. The question is, do you need this one? Answer is no. Because as long as one of them returns hits none, then we're good to go. Let's run that code. I think we're good to go. And let's try the odds. And we're good, and let's submit. Perfect. So it looks like one line of code changed everything. All right, so with that, we were able to solve this problem by going through the linked list multiple times. It took a while, but we got it. And time for evaluation. So the evaluation is O of n time. It took O of n time to split the list. It took O of n time to reverse the list, and it took O of n time to go through the both lists. This is O of n divided by 2. This is n divided by 2. This is also n divided by 2. Yeah, but in terms of yeah, if we want to be more specific, it's O of n divided by 2, but essentially it is O of n time. And space is going to be pointers, so O of 1. And with that, we have completed this problem. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.